Let us look at proposition number 33 of book 10 of Euclid's Elements. In this proposition, again, we have a lemma. The lemma says, in a right angle triangle having the right angle at A and a perpendicular is drawn from A onto BC, then the rectangle BC by BD equals the square on AB. The rectangle BC by CD equals the square on AC. The rectangle BD by CD equals the square on AD. And finally, it says BD by CD is equal to AB by EC, rectangles. So let's see how to prove all these four statements. So first thing is, we are given a triangle ABC, which is a right angle triangle, right at A, and triangle ABD is similar to triangle ACD, and both of them are similar to the triangle ABC. Let's take two of these triangles, triangle ABC and triangle ABD. Since they are similar triangles, the corresponding angles are equal. That means the sides about these equal angles are in proportion. So we can say BC is to AB equal to AB is to BD. See here, since we have this proportion, we can take the product of the extremes and product of the means and they will be equal. So this becomes BC by BD is equal to AB square. The way we have to read this is that the rectangle BC by BD is equal to the square on AB. So that is our first statement. And similar to that, we can prove the second statement as well. BC by CD is equal to AC square. How? By taking triangle ABC and triangle ACD. Okay, now let's look at the third one. AD is the mean proportional between BD and CD. Means we can write it in proportion. BD is to AD as AD is to CD. And again, taking the product of the means and the product of the extremes, we can say AD square is equal to BD by CD. Again, we read it as the square on AD is equal to the rectangle formed by BD and CD. Now let's look at the last one. BC is to AC is equal to AB is to AD, since triangle ABC is similar to ABD. So again, we are taking what we had already covered. The only thing is that we are looking at different sides than what we looked at here. Again, product of the means and product of the extremes. So we have rectangle BC by AD is equal to rectangle AC by AB, which is what the fourth statement says. So that is the lemma of proposition number 33. Now let's go to the proposition. The proposition says to find two straight lines incommensurable in square which make the sum of the squares on them rational, but the rectangle contained by them medial. So let's see how to find those two straight lines. Set out two rational straight lines AB and BC commensurable in square only, such that the square on AB is greater than the square on BC by the square on a straight line incommensurable with AB. Bisect BC at D. So we have to bisect BC. So D is the midpoint. Next, we apply to AB a rectangle equal to BD square, or the square on BD, or CD, square on CD, but deficient by a square. And there is, we have already seen this proposition of how to do this. So this is the required rectangle, AE by EB. So this point, let's mark it as E. This is our square, EB square. So AE by EB, this rectangle is equal to CD square and deficient by a square. Describe the semicircle on AB. So let's draw the semicircle on AB. Draw EF intersecting the semicircle perpendicular to AB. So this line we extend it so that it intersects the semicircle. So let's do that. And let's mark that point as F. And we join AF and BF. Now here AB is greater than BC. Why? Because AB square is greater than BC square. And AB square is greater than BC square by the square on a straight line incommensurable with AB. And we see this AE by EB, AE by EB, this rectangle is equal to 1/4 of BC square, deficient by EB square. So what is that 1/4? Remember, this is the square on BC and we took the midpoint and we made this rectangle equal to this square, deficient by EB square. So this square is 1/4 of this square on BC. What this basically means is that AE is incommensurable with EB. And now we can set up this proportion. AE is to EB is equal to rectangle AB by AE is to rectangle AB by EB. AB by AE is to rectangle AB by EB. Looking at this itself, you can make out that AE is to EB because EB measures this rectangle AB number of times. AE measures this rectangle AB number of times. That means AE is to EB. Anyhow. Now, we have seen in the lemma, rectangle AB by AE is equal to AF square. AB by AE is equal to AF square, square on AF. Rectangle AB by BE is equal to BF square. AF square is going to be incommensurable with BF square. Why? Because AE is incommensurable with BE. So since these are incommensurable, AB is same for both of them. That means AF square is going to be incommensurable with BF square. AB is rational. That means AB square is rational. Square on AB is rational. Therefore, AF square plus BF square is rational. Again, why? Because AB square is equal to AF square plus BF square. So if AB square is rational, AF square plus BF square is also rational. Rectangle AE by EB, AE by EB is equal to EF square. Again, in the lemma we have seen this. Also, AE by EB, AE by EB is equal to BD square or CD square because that is how we did the construction. So which means AE by EB rectangle is equal to both EF square and BD square. So EF square equal to BD square, which basically implies EF is equal to BD. Since EF equal to BD, it means BC is equal to 2 times EF. Why? Because EF equal to BD and BD is half of BC. So that means BC is 2 times EF. So, which means rectangle AB by BC is commensurable with AB by EF. Why? Because BC is commensurable with EF. Now, rectangle AB by BC is medial because there are two straight lines AB and BC commensurable in square only. That means rectangle AB by EF is also medial. Now, the fourth statement of the lemma, if we apply, it says rectangle AB by EF is equal to rectangle AF by FB, which means since AB by EF is medial, that means rectangle AF by FB is also medial. So we have found two straight lines AF and FB whose sum of the squares is rational and the rectangle contained by them is medial. So AF and FB are the required straight lines. So that was proposition number 33 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.